Hi everyone. Good evening, good morning. Am I audible? Can someone confirm?
Yes.
Okay, all right. Thank you. So, first of all, sorry for being delayed. There was some technical issue due to which I was unable to join. So, let's quickly get started with today's session. And before that, I would like to thank you for considering this particular course. And we'll get to know some more things around what exactly are we going to cover in this particular course, right? So, I just want to understand a very quick thing from you all. Like, how many of you think uh, diagrams or architecture plays any role in the world of SRE or DevOps? Maybe a quick one or two liner any would like to share from their experience. I mean, it's fine. And any experience around that you can share.
Mean the
Okay.
infrastructure architecture around that?
Mm-hmm.
Can you repeat, Divyansh?
Sure, sure. So what I'm saying is like, what do you think is the importance of any specific infrastructure diagram or let's say some architecture diagrams, UML diagrams? You might have came across all these kind of terms, right?
Right.
Uh, so how much importance do you think these things play in the world of SRE and DevOps engineers?
Okay. I think not specific to SRE, but in general, these will give us idea what details are we planning to build the infrastructure,
Hmm.
and how many components will this involve. So we'll get that clarity around, and how we work in different environments with a specific infrastructure from QA, UAT, and prod. That clarity we get from this picture, and the design is important for us before implementation.
Okay, well said. Yeah, that's basically a correct understanding of, why the architecture diagrams are important. So I guess I already showed you the roadmap of what we are going to exactly cover as part of this course. Let me quickly share my screen. Just confirm once you are able to see it. You can see my screen, right? Okay, I think I'll take that as yes. Mm, yeah. So this is basically the roadmap that we covered, right? And when I'm saying we will be covering the diagram, so I just wanted to place the importance of this very important aspect in the life of software engineers. Uh, this is also important from the perspective wherein, if you'll see that nowadays people are mostly dependent on all these kind of AI ML based softwares, or we call them as LLMs, right? So it's more from the textual and semantics understanding point of view. But when it comes to the blueprints, when it comes to the design, when it comes to the understanding of a particular system, that is where even they are not that great and sufficient, at least at current point of view. If you'll consider current time, if you'll consider at the moment for any specific LLM, they are not that great at that to comprehend whatever diagrams that you'll give to them or you'll ask them. So the reason behind that is there have been very few architect experts in the software industry from the beginning of this entire phase, right? So you can just imagine this as just as any contractor whom you would hire to build you a house. So they won't be able to build a house by simply guessing where the plumbing goes, uh, where should the electric wires be placed, right? All those kind of things need some kind of diagrams to visualize, and that is where we have some kind of house maps. They create some floor plans and all those kind of stuff, right? Which means for any engineer, be it a software engineer or any other engineer, they need to visualize, they need to communicate through the patterns, through the designs to validate the structure of what they are going to build, right? So the same thing applies to here as well. All the software projects that involve, let's say, maybe diverse stakeholders from all the product managers and investors to front end and back end developers, right? So a well crafted diagram, a good design goes a long way. It just abstracts away the code and then it presents the system in a way that everyone can understand. So I think it is important from another aspect, which is to identify any bottlenecks or any risks at the start of your process. Because let's say if we are doing all the deployments and then at the end we are saying that, sorry, someone from your team, from someone from your architect's team or your senior management now is saying that this is a blunder that you have made. You have not included the disaster recovery mechanism here, and you have not considered the security vulnerabilities. These are some performance choke points. All these things are, you know, coming to you at a later point of time. So that is something which will bring you down to this state of confusion, saying that what should be done now. And it won't be cheaper also because you have invested a lot in provisioning the resources, in deploying the resources, right? So that is where, for a good SRE, for a good DevOps engineer, it becomes very, very crucial to understand how these diagrams work in reality. Now, it's completely fine if you don't have any understanding of any specific category of the UML diagrams. Like UML diagrams uh, was a term which was coined way back. It was basically a way through which, uh, people could interact within the ecosystem. Let's say if we'll talk about any enterprise, people would be able to share their views such that it acts as a bridge between the technical layer as well as the product layer. So they used something known as the unified modeling language, and it includes multiple diagrams. Let's say if you're starting with some particular project, if you're joining a startup, uh, it's very likely that you will see people discussing in their initial phase with the use case diagram. They'll see, okay, who all could be the stakeholders in this particular ecosystem that we are building, and then they'll progress towards the the class diagram, sequence diagram, right? All these kind of diagrams are there, and these diagrams basically form the base of your understanding. That is where, even if you'll go for any specific interviews, any recruitment process, uh, there is a very, very crucial phase which I think nowadays is given even more importance. The reason behind that, I think we already discussed at the beginning of the session. Uh, Even though if you are very good at using any AI LLM tools, you might not be able to beat someone who is rather expert in these kind of diagrams, right? So even in those kind of interviews, you would be asked, okay, explain this particular. Nowadays, I think there are two types of interviews how they are conducted. So ideally, it is something like they'll ask you to design it, right? And then the second thing could be, now they ask you, they'll present something in front of you, and then they'll ask you, just walk me through this diagram. What's your understanding on this? And what do you think this particular thing was selected? So that puts you in, I would say, even more tricky situation wherein you need to show some understanding of uh, that particular resource which was used at that particular place, right? So the idea is like all these things play a good important role, and we'll try to understand from the infrastructure point of view how exactly a diagram would look like. And then this particular diagram which you are able to see, this is something which is going to be our source of truth. So that is why following a specific startup process, a particular enterprise process, the way they progress from designing to the deployment, that is what we are going to do. So we'll try to focus on the design part first. I hope you all might have got the idea of what exactly we are trying to cover here, right? So let's quickly get started with this. Now, depending on who you're talking to, you might use different views for this particular architecture, which you are seeing, right? So here, what do you think? Like, what picture is this diagram giving to you? Anyone? Quick one word answer.
Like a flow diagram.
Flow diagram. Okay. Uh, okay, that's fine. So when you're saying flow diagram, it means that you are able to get picture of a particular flow, right? That means you are able to understand that, okay, from where the things are flowing where. Uh, but then let's say if we want to discuss on some particular area, let's say if you want to discuss on the observability part, so you should get an idea of where exactly the observability here uh, resides. It's residing here, Grafana, Prometheus. So this entire layer is something which will give us the idea of the monitoring part. And then if someone asks us that, okay, what is this particular cloud? What is the cloud provider that is being used? Why are we doing this on Kubernetes? Why Azure? Why not just a VM with Docker, right? So this is where you'll get the answer. You need not to explain much on these very, very basic things because these are pretty much explanatory when you're taking a look or when you are designing these kind of infrastructure diagrams. So it gives you a high level overview of how your infrastructure design would look like, right? So let's start with the question that we just kept, right? Why are we doing this on Kubernetes? Or let's say why we are using the
High
Azure.
availability
Hmm. Okay, good.
and self-healing.
Very good. All right. And why Azure? Anyone?
Cost saving,
Okay.
and
So,
availability of multiple regions, latency, if we are in different regions, like based on the user community, like the users.
okay, that's good. And why not we could just build this thing around, maybe using a Docker within just a VM?
Azure will manage all the
Scale,
network
scaling,
related
yeah.
infrastructure, setting up subnets, all that.
Scale up would be the challenging one if we are doing it.
Exactly. I think all of your answers are correct. Because if you'll remember in the roadmap thing which we discussed in our previous session, we discussed that we want to get an overview here of how exactly the production grade systems look like. So we need to think from those requirements. Like just you mentioned scalability. That is something which we need to think of. We need to think of the elastic scaling here. Let's say the traffic is spiking. Now your infrastructure must scale automatically. Then you mentioned about the availability part, right? Which is considered as a very, very crucial non-negotiable requirement. high availability. It means your service needs 99.9% uptime. Now, this is a very, I would say, funny and a common scenario which we all might have seen. So, just a kind of a fun fact, like what do you think people claim 99.9% uptime? Why it is not 100% uptime? Okay,
Is it
let me
because
tell.
of the maintenance windows which are being provided as per the applications? They say like, okay,
Mhm.
we like for means for patching or upgrading.
Yes,
Still, it should be 100%, but means all the time it should be available. But still, these are considered as like that one point,
got
not
it.
one.
Good. Yeah, that's correct. So I think I'm pretty much sure we all might have heard of different outages in our life. In the recent times also we have seen very good number of outages. The recent one I think was day before yesterday for most of the European regions for AWS, right? Due to which all the companies, all the enterprises were facing a lot of challenges, right? So even though AWS, Azure, or GCP, Google, they are kind of epitome in the cloud industry. They are known as the best of cloud providers. But even then, they also are facing these kind of outages, right? Which means it is not something that is unavoidable. You can have these outages, and it's completely fine because, as you pointed out, right, there could be some kind of maintenance, let's say, some patch was applied as part of some rolling updates, and then maybe it might have just broken down some particular connectivity layer. It might have affected something. Before this AWS outage, there was this Cloudflare outage, which basically shook the entire internet itself because you might be knowing that our internet usually requires that Cloudflare layer at the very bottom. So these are the things, which are playing a very crucial role in even designing the SLAs. So that's why they place it like 99.9% uptime. Now, that's only 43 minutes of downtime per month if you'll consider it from the entire yearly scenario. So that is how they decide that, okay, this is something that needs to be the uptime factor. Then the fault tolerance is something which needs to be taken care of by just looking at it. What if the nodes die? What if the disks fail? There needs to be some kind of the network partition. Your system must survive, right? And then if you're talking from the monitoring perspective, which we already covered, so when things are breaking, at least you should have some visibility, right? Let's say that AWS outage was there, so they have a very decent observability system that it not just notifies their team, but it will also notify the common public. There's a portal by default which AWS exposes. By going over there, you can get to know that, okay, they have close to 35 regions, if I'm not wrong, in total. Some of them might not be visible to the common public because they are basically for US government and some other governments. So if you'll take a look at that particular monitoring portal, you will be able to identify that, okay, this particular region, there is the outage. This particular region, there is an outage, right? So that is, I think, that is why all these Netflix, Airbnb, Twitter, they all use these kind of patterns. And this is why we'll try to understand this particular diagram. So we'll just do a quick walkthrough of this together, right? And layer by layer, component by component, we'll just pay some close attention to it. Now here,
Can we increase a little the font because the font is very small, right?
mhm,
Unable
okay.
to read that.
How about now?
One more number.
Okay, all right. So now look at the diagram. Let me let me know what do you think should be considered as the entry point of this particular diagram. Let me give you a full picture of how the diagram looks like, and then you can tell me from where do you think should be the entry point of this particular diagram.
End
So
user.
let end users, very good. Now at the top you'll see the SRE team and the end users. Now they are hitting your service from the wild internet. So why do we say wild internet? It means this is the first question that you should ask. How do they reach your application running inside a private Kubernetes cluster or any inside an environment that is hosted on a very, let's say, secure cloud-based environment, Kubernetes environment, and how would they reach your particular service? How would they reach your application, right? So the answer is there's this ingress layer, which we also call as the load balancer. You can call it as the ingress controller. So it runs on this 20.115.178.44. So this is where our Nginx ingress controller is sitting. This is something which you can consider as your front door, right? So just in our house, we have the main front door. Now, there is no possibility that someone else could enter your house unless they are using some, uh, they're breaching some Windows firewall or those kind of things. Your house windows, I'm talking about, right? So it's also known as L7 layer. L7 means you might be aware about there are 7 layers in our OSI model, right?
Yeah.
Uh, is there anyone who is not aware about that OSI model? Okay. So even though if you don't have much idea about that, maybe you can quickly Google it later once the session concludes, and you can get to know. So ideally, when in the world of architecture, in the world of SRE, in the world of DevOps, right, people usually discuss on these layers. They'll say there's some issue at the L5 layer, or they'll say there's some issue at the L7 layer, right? Which means they're discussing about these particular layers within that OSI model. So layer 7 is known as the application layer. And here basically it's if we'll talk about this particular thing, right? So what we are doing, it's a layer 7 reverse proxy that is running as the Kubernetes load balancer service. So here's the reason why it becomes even more critical, because let's say all your HTTPS traffic, it gets decrypted here. You might be aware about these two terms, encryption and decryption, right? Encryption means when you're trying to secure your particular message, your, let's say, transmission is being secured using uh, some encryption protocols, which are basically falling under the category of cryptography. All these encryption, hashing, all of these are very common terms over there. So we are
చేశాడు నువ్వు
using,
జస్ట్ వినటమే కదా.
okay, thanks for muting. Yeah, so we are using this some kind of encrypt certificates which are managed by the cert manager. This means there might be some kind of automatic certificate renewal. Uh, you need not to be awake all night for the certificate expired incidents, right? So that's why we are using this Let's Encrypt certificate manager here, right? And then we have the request routing here in this particular layer, which means a single IP will be handling all the traffic. So it's not like a user needs to enter 2 to 3 IPs. Let's say he'll enter first IP, he'll land on some particular platform, and then that particular user needs to enter some other IP now. So the system will say, okay, now you have reached this layer. Congratulations. Now enter other IP. Right? It's not like that. It should be uh, a single IP that must handle all the traffic. So the ingress controller looks at this host reader, or sorry, host header, and then it routes back to the current backend service that is running here, right? Now there are some couple of other things which we'll consider. For example, you might have heard about these common scenarios like the rate limiting or maybe the DDoS protection. So what are these things? These are like, let's say, if you are a malicious user and with some malicious intentions, you want to, maybe hit my particular website or web application with a tons of load, which is not an actual traffic, which is not an organic traffic, which means you're trying to manipulate the network, you're trying to bombard the network with some kind of malicious intentions and transactions hitting it continuously. So it might either break my server, or it might get it into the situation where there would be a denial of service, which means I might not be able to access that particular resource for some indefinite amount of time. I'm not sure how quickly the server would recover, but that is why we need to limit the rate for a specific service. So all these things, uh, I think you can configure here in this particular layer. There is a protection which I mentioned, DDoS protection. So it's distributed denial of service. It's a very common term in the networking world. So I mean, without this, basically anyone could overwhelm your network. So just to give you an idea in short, that's why these kind of layers or security protocols needs to be enabled. So then we have the Azure cloud infrastructure layer, right? Let's talk about what's running this. And since we already discussed, like this is something which we are doing on the Azure cloud. Now you could do the same thing on the AWS cloud as well if you are an expert in AWS. If you feel you have more expertise in Google Cloud, then you can use GCP, right? So what do you think? Which region are we using here for from Azure? Any idea?
Region is west or something.
West US2. That's
West
correct.
west.
Exactly. Yeah. So this is how a diagram would help you. Going forward, let's say if someone is asking you, hey, can you quickly help me with the resource group name? What is the resource group name? So all those things usually are mentioned at the diagram level itself so that it gives you a very uh, focused understanding of how well the things are mentioned within the document, within
Yeah,
the
it
diagram.
helps the SRE also to quickly check that instead of
Exactly.
reinventing the wheel completely. Yeah.
Exactly. Exactly. That's correct. Yeah. So why Azure or why any cloud? Again, I would give just few reasons. First of all, global infrastructure, as we discussed. Azure has close to 60 plus regions. It has very low latency worldwide. Uh, then, when it comes to the enterprise integrations, it has a very, very great feature which we all have definitely used once in our lifetime, which is known as the Active Directory, right? So, even our Windows platform is very well equipped with the Active Directory. So, all the things that enables you to call it as a PC or a personal computer is something that you are able to do because of these Active Directory principles being applied on your Windows ecosystem. Uh, and then if you'll get on the Azure platform, then it becomes Azure Active Directory, and it has some other principles, some other features to be applied to your infrastructure, right? And then we have Key Vault, we have Azure Monitor, we have n number of things which you can play around with, which we can use throughout your application. So it's more from the cloud native perspective. Now, there are two ways of using any particular resource, any infrastructure. One way is very simple, where you can depend on the cloud provider. You can say that, okay, hey Azure, I would be interested in using your this service. Now you would be interested, but Azure would be even more happier to provide you with that service. Why? Because they get to charge you for that particular service, right? It is not coming for free. Everything is chargeable here. So the more add-ons or the more services that you will use from Azure or any particular cloud, the more billing you will add to your current month billing cycle, right? Now, this is something which becomes very crucial from a DevOps engineer perspective, from a DevOps architect perspective, that you should be very well aware about where you are unnecessarily spending your costs. So you should be asking this question that do we really need this particular thing? Can we scale it down if not needed? Or should we make this thing scalable such that, if in case there is no traffic, it should scale down to the minimal limit possible, right? So all these things are possible when you have some kind of a managed environment. And that is where for Azure, it is AKS. For Amazon, it is EKS. So it's the Azure Kubernetes service. It becomes a fully managed Kubernetes service wherein you need not to handle it yourself, but then rather Microsoft will handle the control plane updates, all the etcd backups, all the master node high availability thing would be the responsibility of that particular cloud provider, right? So, but it comes at a cost, right? So either your organization might decide that, okay, let's not take the pain of managing or handling all these updates, all the backups, high availability part. Let's use whatever the cloud is providing. But then at the same time, your organization might also think from the cost saving perspective, and they will ask that no, we'll not use the the managed Kubernetes service. We'll use our own. We'll be deploying our own Kubernetes. So that is also possible. So you should be having a good knowledge, a good grip on that particular aspect as well. So we'll try to cover those things as well here in our session, in our course basically. So here you'll see two resource groups. Can you quickly name what are those two?
AKS RG is there, one resource group,
Hmm.
and
And
Good,
dev. Yeah.
good. That's correct. Yeah. So we have two resource groups here. There's one resource group demo, which basically contains our Terraform state backend, or you can call it as the storage account. Now, why separate? You might have this question that why do we need two resource groups? It first of all, it depends on how many resource groups you want to create in the Azure. Like you have this uh, freehand, you can create multiple resource groups, but then there is an intention behind it. Why do we need multiple resource groups? So by the name itself, it should be clear that what do we mean by resource groups? It means we are grouping the resources based on some context, based on some intention, right? What is that intention? Now, that is something that you need to ask yourself. You need to ask uh, based on your knowledge, based on your understanding, why do you want to separate these things? Because your state file would be the source of truth for your infrastructure, which means if someone deletes your main resource group, your entire platform is gone. But if you're separating it out, you are separating your state file, which is something you are considering as the source of truth for your entire infrastructure that is being deployed. So even though if someone deletes your resource group, other resource group, your main group will still be having the Terraform state intact, and then you can recreate everything. This is the best part about the Terraform. This is the best part about the Terraform states, and this is the best part about the resource groups. So this is something which you can consider as a disaster recovery 101 scenario, right? You can also consider it as the first lesson from the disaster recovery point of view, which is a production grade practice. And then we have the next resource group, which is the AKS RG here. So this is something which I would say maybe you can consider as your production environment. Now inside this you have this ACR. What is ACR? ACR is an Azure Container Registry, just like we have the Docker registry, right? Uh, so Docker registry is something which, let's say, if you're very new to the world of DevOps, you just quickly ran this command, Docker run, and then whatever image that you had. Now, let's say that image is not there on your system. What it will do is it will try to go to the Docker hub, which is the public Docker registry, and then it will search for that image and it will download it on your system. So the same way, Azure provides you the option of uploading and maintaining your own images, your own Docker images, which are specific to your project, specific to your organization, right? So that is how they termed it as Azure Container Registry or ACR, right? Now here we are using the ACR, this one. Uh, so this is, as I mentioned, right? Like there are a couple of intentions behind using the private Docker registry. And as I mentioned sometime before, that you will have an option to switch to the open source resource at any given point of time. But you need to think from the trade-off perspective. What is it something that you will compromise? Now here, maybe any one of you can try to answer. What do you think would be compromised if I'm using a public Docker registry in place of ACR?
So public registry, anyone can like yeah modify. Like means we might get a vulnerable images also. Like anyone can
Good,
just modify
good.
it.
Yeah. So that is one thing anyone can modify. And then the second thing is anyone can pull them. Let's say if your image which you pushed over there to the public repository, right? Now it was having your source code. It was having your uh, I would say something that you were working on as a very native solution, which was not existing in the market, and now you very happily uploaded it to the Docker public repository, public registry, and now everyone is having it, right? So
And it is
the re
easy for a hacker or a bad actor to get
exactly.
into. Yeah, that's like main thing.
Yes, yes, correct. So from the security standpoint, your application images here would stay private. No one will be able to pull them without the credentials, which we need to set while we'll be working on with the ACR. And then other things are like from the speed and compliance perspective, I think it becomes crucial that all the enterprise companies would require that images should never leave their cloud environment. So this is also one of the things which they'll specify in their uh, SLAs if you'll dig deeper into that, right? So ideally here what is happening is if we'll talk about this particular application. Now this is our application which is built using Golang. So your this particular application will pull its image from here, right? So you can notice this particular connection. So there would be some kind of an image pull secret authentication which will be happening in action so that it will authenticate that okay the the proper user is trying to access that particular image, that there should not be any specific uh, outsider who's trying to gain access to that particular image which is having the running logic for that particular application. And then we have this Kubernetes cluster here. So this is the core of the deployment, or we can say this is the main orchestration engine where the magic happens, right? So even before we dig deeper into our upcoming sessions on what Kubernetes is, let's have a quick walkthrough of what Kubernetes is. You can just think of it as an operating system for all the distributed applications, right? As you already, someone of you already mentioned that you will be able to declare what you want. Uh, I mean, it's a self-healing based application. So you can declare whatever you want. Let's say you want uh, 4 pods, 5 pods, 6 pods. You can have the desired state over there, and then Kubernetes will make it happen for you, even though some specific pods will go down. It will again heal them. It will be able to rerun them, and that is something which is also known as the state reconciliation. So this is something which becomes very crucial for any enterprise, any organization which is looking to have this kind of a safety mechanism for their deployed application. So they want it to be managed somehow that it keeps on intelligently orchestrating itself. So Kubernetes is something which becomes must here, and then it comprises of this cluster which has the multi-zone deployments. The nodes would be, uh, spreading out across different availability zones. So this is something you might have seen while creating your virtual machines. It asks you I mean, whether do you want to have the availability zones, and then it gives you the option also 1, 2, 3, and whatsoever. And the same thing applies here to the Kubernetes cluster as well. Like it has node pools. Uh, so node pools are something which I would say includes two things. One is the system pool, and other thing could be the workload pools. So the difference is system pool is something, by the name it should be clear that it is something that Kubernetes says, hey, this is my space. I want to keep my internals here. So it's not for your purpose. It's not for your use. Unless you want to make some changes to me, don't touch this particular pool. That's how it could be recognized as. And then there is this workload pool, which you can consider as where your application files or your application logic would be residing. Right now, when we are saying the node pool, it means it is a collection of nodes, right? So it is up to you how many nodes you want to keep over there. Let's say if you want 2 nodes, if you want 3 nodes, if you want 4 nodes, depending on your scaling requirements, depending on the resource pressure you feel, you can opt for these options. And then we have something known as the namespace. So namespace is also an internal thing which we'll cover in our upcoming sessions. But if we'll just talk about the namespace from the layer perspective, let's say monitoring layer, ingress layer, application layer, data layer. So within the Kubernetes cluster, if you'll see, these are acting as the namespaces. So this is how exactly we will design our virtual clusters. So I consider these namespaces as nothing but the virtual clusters, right? Uh, so if we'll talk about this one, which we already discussed, here lives uh, the Nginx ingress controller with its load balancer service, right? And then we have the application layer where our Go transaction API is sitting. So here there are some other couple of things as well. Like let's say if in case you want to have some kind of some deployment configuration, some rolling updates, some health checks. So all those things you will be configuring here at this particular layer in this namespace, right? And then we have a data layer. So what do you think data layer is doing here? It is the storage house of your particular architecture, your infrastructure. Uh, Now you would be having, in terms of Kubernetes, if we'll talk, there would be some persistent volume claims, PVCs. So again, this is the storage, which is usually if you are using the Azure managed disks, it would be taken care by Azure itself. Uh, it could be useful in all the scenarios where you mentioned about that self-healing part. So let's say if the pod dies, where is it fetching the data from? It it needs the data, right? So the data survives here in the data layer. The volume which is there, it gets reattached to the new pod immediately. Uh, so this is also something which we'll try to cover using some of the commands. We'll try to practice it out, how it works internally, right? And then we have the main final layer, which is known as, or which is known here as the monitoring layer. This namespace is something where I would say SREs have a very crucial say. Out of all these layers, which are more pertaining towards the DevOps part, SREs have uh, some increased responsibilities within this particular layer. So we need to consider here from the metrics perspective, which will be given by Prometheus, from the logs perspective, from the traces perspective. So all these things would be taken care by the Prometheus. And then if let's say if you want to visualize that particular thing, so what it will do is you need you can consider Prometheus as your query engine. It will query whatever you'll ask. If you'll say I want to have my API latency, it will query it for you. If you want to see, hey, what is the transaction failure rate? If you have written those kind of logic, it will it will fetch it for you. But it's a query based engine, right? Now, some people are not uh, they don't like to use the CLI based things, or they don't prefer to look at some query based engines, like they have to manually type in the queries or those kind of things, right? uh, they want maybe something which could be visualized, something that could be exported as the data, and then that data is coming to you in various visualizations, like by it could be bar charts, pie charts, histograms, heat maps, all these different visualizations, right? So that is something which will be possible if you have something like Grafana. So Grafana is uh, an open source, I would say, real-time dashboard provider for your internal, you can say internal things that are happening, whatever configuration that is running, whatever uh, things that are happening behind the scenes, which Prometheus might be handling, all those things could be visualized using Grafana. So this is something which usually would be deployed as a tool wherein the SRE would be sitting and he'll quickly have a glance at it. And then if in case there is any alert which is triggered at 3 a.m., 2 a.m., that, hey, there is a very high latency, what you will do, you'll quickly open the Grafana. You see, okay, database query has time spiked from, let's say, 10 milliseconds to 900 milliseconds. What you'll do, you'll check from here itself, you'll check if the DB connections are active. You might see that, okay, no, it's at max 100 out of 100. The pools are exhausted, right? That could be the root cause. What you will do, you need to have a mechanism in place. Now, all those mechanisms, either you should be aware of if you are a very experienced candidate, if you're a very experienced engineer, you should be aware of about all those things. But let's say if you're new to that world, so you should not panic. There are some things to help you out over there, and those things are known as the run books, right? So that is also something which we have as as part of this course. So we'll try to understand how those run books will help you in diagnosing a particular scenario. So you need to write the run books, because from an SRE perspective, from a DevOps perspective, it is your responsibility. Whatever you are deploying, it should be documented in such a way that even though if I'm running some command, it should not fail, saying that, this this skips maybe 2 to 3 steps, and then you are just running that command, and that's how you are creating that documentation. So that might not be considered as a proper run book. So it is also a very, I would say, important factor or a criteria when it comes to the SREs. So we'll try to cover that as well as one of our sessions in our upcoming course. Okay. So this was more about this entire infrastructure diagram, how exactly we are configuring things, how we are setting the rules, how we are scraping the metrics from our application. So these different blocks here should help you identify how we have defined our application. We have isolated, we have partitioned the resource groups, we have partitioned the namespaces based on the logic, based on our use case, right? So that is how exactly you should make the most understanding out of any given diagram. And if in case someone is asking you to design some application, someone is asking you to think of an infra for an idea that has been given to you. So this is how exactly you should be coming up with. You can have maybe some other rough diagrams to begin with, and then those could keep getting refined. So this is about the diagramming part. Uh, Now, in our upcoming lectures, we'll try to dig deeper into each of these sections that we have. So even taking a step back, we would cover from how to approach a scenario wherein, let's say, you just joined an organization, right? Now, you are the only person over there who has been given this responsibility to, let's say, bring a new service to the life. So these are the jargons that might be used. They if they might ask you to bring that service to the life, that means you need not to use some spells, but you need to provide them with something like this. And not just the diagram, but also you should have a thorough understanding of reading the SLAs, understanding the parameters that might be needed for each of the layers, and then proceeding with the deployment. But that comes as a step-by-step process, which means first you would be designing, you will be collecting the requirements from all the architects, uh, your product managers who are there, and then your backend team. You might be consulting with them as well. That hey, how many applications do you think uh, our backend is running? How many services are there? Is it a microservice based diagram? So all those things we'll try to cover in our upcoming session. We'll try to understand how or what you should conclude from that discussion which you are having within your team, and how would you come up with some kind of an SLA, or how would you walk through it, how would you go through it, and then we'll slowly step towards this production grade deployment. So this should give you a walkthrough of a real scenario wherein you should feel that okay, you're working in some particular organization. And then if you'll consider it from that perspective, it would become even more easier for you to comprehend these things. So I think I would like to open the stage for you all to ask any questions if you have.
As part of this course, are we going to uh, means like practice something on the open sources? Like you mentioned, like we have
Hmm.
Grafana, the open source where we can just
Yes.
load some sample data and just have this.
Hmm. Yeah. So I think the practice thing is something which, I would leave it up to you. But all these
Okay.
things which are mentioned here from, let's say, from a deployment perspective, let's say, so we'll come to a common consensus wherein we'll decide that, okay, this is something. Firstly, we'll still have some more discussion in the later course around that. Okay, we all should
Yeah.
agree to a common consensus that do you agree with this particular design? Do you agree with this particular architecture?
Okay.
Now, once we all are on the consensus, then we'll proceed for the deployment for that particular infrastructure, right? Now, it could include some of the open resource uh, tools like Grafana, Prometheus, or it could include something which is Azure based. So I would be walking you through each and everything, and it is up to you. Let's say you still want to gain some some more expertise. You want to build some more expertise around that. So I can share you the resources. I can share you the link. You can open some trial account for Azure, and then you can practice this on your own. Uh, so yeah, I mean, like it depends. Like the more you'll practice, the more better I would say the more expert you will
Yeah,
become in
means
this
what I'm
particular thing.
asking is like, I'll put it in like, will we get like scenario-based assignment saying so that we can just try something and we can brainstorm ourselves?
Yeah, sure. I mean, I can. So if you're considering it as some kind of a home assignment for at the end of every session, it's not something that we would be discussing again on the next session because we want to keep these sessions compact size because I think we all
Yeah,
are working professionals, right? So we might not be having that much time. So you can practice at your own pace. You can practice at your own discretion, wherein you can always uh, troubleshoot if in case you are facing some issues. But yeah, I can give you some of
yeah,
assignments if you're interested.
yeah, yeah,
That could be done.
yeah. Thank you.
Any other questions? Okay, all right. So I think maybe Dinesh, do you have anything to add here?
Oh no, Devansh, pretty good. Yeah, thanks for the
All right.
session, Devansh.
Thank you. Thank you all.
Thank you.